I'm a digital circuit designer from Korea. I designed the base die of HBM, this part right here, at the bottom of the stack. To keep up with HBM's bandwidth, the base die has to be designed with area, speed, and power under tight control. Getting this wrong is expensive. We design chips in a language called RTL. At first glance, it looks just like software, but every line here describes a physical circuit. Look at this example. Functionally, nothing seems wrong when the condition is true. The data goes through. But when this becomes hardware, there's no default value for the other case. So SynthRisk creates a latch, a circuit that silently holds its previous value. Now imagine this module instantiated dozens of times across a chip. That's wasted power and area everywhere. And in the worst case, a silicon respin. A respin typically costs millions of dollars. So we designers run a lint tool to catch problems early at the RTL stage. Here's Variable, Google's open source linter on that exact file. But Lint is rule-based. It knows the rules, not the circuit. Look, nothing about the missing else. The one issue that becomes real broken hardware is the one it never mentions. And every warning gets equal weight. On a real design, this report runs hundreds of lines, and the designer can't tell which ones actually matter. That's why I built SynthRisk. It takes the lint results, plus the source, and uses GPT-5.6 to judge the circuit impact of each warning. It sorts everything by severity, so the designer sees at a glance what actually needs fixing. Let me show you. Same file, through SynthRisk. There it is at the top, marked critical. The missing else, the linter never reported. Flagged as AI detected, with a plain language explanation of why it becomes a latch, and a suggested fix. Note, it only suggests it never rewrites your RTL. In hardware, automatic edits are too dangerous. And here's the whole examples folder at once. Risky files, ranked by severity. The architecture is deliberately simple. An AI wrapper around a lint tool, with GPT-5.6 Terra reasoning over the results, one API call per file. I built the entire tool with Codex on GPT-5.6 Terra in a single day. Simple to build, but the potential is huge. Today it supports Variable. The same triage layer can wrap Synopsys Spyglass and other industrial tools. The linter knows the rules. SynthRisk knows the consequences.